Good day to all of you. Welcome to Easy Physics. Learn physics as easy as 1 to 3. Today's video is mainly for students of class 10th, and through this video we will discuss the first topic of the lesson, electricity. In this lesson we will study electric current, what are the properties of electric current, factors affecting electric current, and the law which regulates the flow of electric current, which is nothing but Ohm's law, and one of the practical application of electric current, heating effect of electric current. Let's look into today's topic. It is nothing but electric current. Before we study what is electric current, let's have a quick recap of one thing which you have already studied in smaller classes, which is classification of materials based on electrical conductivity. Everybody might be knowing that materials can be classified into three based on their electrical conductivity as conductors, semiconductors, and insulators. Let's have a bit of chemistry understanding of conductors, semiconductors, and insulators. I hope you all might be knowing what is atomic structure, right? As per Rutherford model of atom is considered to be having a structure in which positive protons and neutral neutrons are kept at the center of the atom called the nucleus, and negative electrons are revolving around the nucleus in circular orbits, right? So these are considered as the nucleus of atom, and there are different number of orbits around the nucleus, which basically depends on the atomic number of the atom. Now, we are mainly focusing into the nucleus and only one of the orbit, which is called the valence shell. Valence shell means it is the outermost shell of any atom. And the electron which are revolving around the nucleus in the outermost shell is called valence electron. Conductors, semiconductors, and insulators are having a basic difference in the number of valence electrons. If a material is having 1 to 3 electrons in the valence shell, they will be conductors. And if a material is having 4 electrons in the valence shell, they will be semiconductor. Or if a material is having full valence shell, maximum electrons that can accommodate in a valence shell is going to be 8. So if a material is having rather 5 to 8 or 6 to 8 valence electrons, we call them as insulators. They will not be able to conduct electricity at all. Let's see what makes them so special that some of them are able to conduct electricity and some of them are partially conducting electricity and some of them are not able to conduct electricity. For that, let's first look into the structure of a conductor. In this, I'm showing one electron in the outermost shell. Look at that electron which is far away from the nucleus. Nucleus is positive and electron is negative. So these electrons are able to move in orbits just because of the attractive force with which the nucleus is attracting the electron. This electron, poor fellow, he is all alone in the valence shell. So anybody can easily come and kick that electron out of the shell. Isn't it so? Because the electron is all alone there. So maximum 3 electrons will be there, and these 3 electrons are weakly attracted by the nucleus. As a result, temperature, room temperature. Temperature means it is a form of energy. Heat is a form of energy. So room temperature itself, the heat present at room temperature itself will be able to withdraw or taken out the electron from the valence shell of most of the conductors. Mainly metals are classified as conductors. So in metals, at room temperature itself, these electrons will no longer belonging to the atom, but they will be free from the valence shell because the heat energy will be sufficient to kick this electron out from the shell, and these electrons will be free to move on the surface of the metal. If you take a piece of copper, in that there are n number of atoms, right? So from each of them, one or two electrons are taken out, means there will be so much number of free electrons present on the surface of these metals, right? Now let's see what happens to semiconductors. In semiconductors, there are four valence electrons, which means the valence electrons are bigger in number. So it is not as easy as in the case of metals to take out these valence electrons, right? As a result, some of them may be coming out when the temperature increases, whereas some of them will not be able to come out because more energy is required in order to take out these electrons from the valence shell because they are bigger in number. That is the reason. Now let's look into insulators. They are majority in insulators. Number of valence electrons are more, maybe from 6 to 8, which means they are strong enough to be in the atom. They don't want to come out of the atom. As a result, these electrons are not free. If they are not free, they won't be able to move freely. That is why insulators will not be conducting electricity. In conductors, electrons are free because their ionization energy means the energy required to take out an atom from the valence shell is very less. So in most of the time, these electrons will be free. They will not be revolving around the atom. Have a close look at the structure of a metal and a basic insulators. In a metal, there will be free electrons, as I told you how the electrons are formed. And when the electrons are coming out from the atom, these particles are called as what? Ions. They will be gaining a positive charge, right? So in the metal surface, there will be free electrons as well as positive ions. Whereas in the case of semiconductors, it is not only semiconductors, in insulators also, it is not only about the attraction between the valence electron and the nucleus. When you have a close look, see, these electrons are getting attracted by the neighboring atoms as well. So they are having a very strong bonding. As a result, it is not so easy to take out this electron because this electron is under the influence of one atom as well as its neighboring atom. That is why in insulators, it is not possible at all to take out any atom. Now, let's forget about insulators. We are going to concentrate only on conductors and the current which is flowing through the conductors, right? I told you when a copper piece of metal is taken, there are free electrons on the surface of the copper, right? But if you keep a piece of copper metal there, will you say that electric current is flowing through the copper wire? No, right? Unless and otherwise you connect it to a battery or a source of electric current, copper will not be having any electric current. Even though free electrons are present, we will not say that current is flowing through it unless you connect it to a battery. Battery means it could be any source of electric current, right? The reason is when the copper piece is kept without giving any electric current source, the movement of electrons will be in random direction. See, one might be going in one direction, the other electron might be going in this direction, the other electron might be going in another direction. This cannot be called as electric current. In order to call the flow of charges as electric current, all these electrons should be moving in a specific direction. For that, we need to connect it to a battery. Battery will be having a positive and negative terminal. Let's look at a cross-section piece of a metal. Let it be copper itself because it is one of the most familiar conductor for us, right? Inside the copper piece of metal, there will be electrons, which I am representing by using these blue dots, and there are ions. These ions are not free to move, whereas electrons are free to move. As you know, electrons are negatively charged particle. So when the negative terminal of the battery is connected at the side, this negative terminal will repel the negative charged ions. As a result, electrons will start moving from left to right. Then there is a positive terminal of the battery connected at the opposite end, which means obviously these negatively charged particles will be attracted towards it. So which makes the movement of electrons in a proper direction. That is, they will move from left to right by overcoming the resistance opposition offered by the ions, metal ions. So based on different types of materials, even though some of them are classified as metals, for example, aluminum, copper, silver, all these are metals, but they will be having different level of conductivity. We will study what makes them unique about their level of conductivity in the forthcoming video. Okay, now I hope everybody understood what is drifting of electron. This unique direction movement of electrons when source of electric current is connected to it is called a drifting of free electrons. Otherwise, if negative positive terminal is not connected, these electrons will be in random motion. We cannot call it as electricity. So electricity, in order to call that electricity is flowing, it is drifting of free electrons in a proper direction. Hope it is very clear. Before we define what is electric current, we need to be familiarized with one more physical quantity. It is electric charge. Electric charge is a physical quantity. Physical quantity means it is the property of any material. It has to be a measurable property. Electric charge is nothing but a specific property of a material which enables the material to experience electric force. That is, only charged particles will be experiencing electric force. As you know that charges can be of two types, either positive or negative. Electrons are having negative charge and protons are having positive charge. Electric charge can be represented by using the symbol, because in physics symbolic representations are very important while we do the problems, while we study the mathematical formulas. So electric charge is given the symbol Q. You can use small q also. Capital Q and small q are accepted for the representation of electric charge. So electric charge is nothing but the characteristics of a material which enables the material to experience electric force, represented by the symbol Q. All the measurable quantities must have a unit, right? For example, length. When you measure length, you should say it is in meters or kilometers or centimeters. Likewise, electric charge also should have a unit. In SI system, charge is measured in coulomb, and we will be using the symbol capital C to represent coulomb. For example, if somebody is writing a charge of 10 C, you should read it as a charge of 10 coulomb. Clear? So electric charge is defined as the property of a material which enables the material to experience electric force, represented by the symbol Q, and is measured in coulombs. There is one special property of electric charge which you need to know: quantization of electric charge. Quantization of electric charge means it is believed as of now that is the smallest possible charge in any material is the charge of an electron. And any other material can have integral multiple of electronic charge. Integral multiple of electronic charge. Mathematically, we can write quantization of electric charges. Q is equal to N times E, where E stands for charge of electron. Its value you should study. It is 1.6 into 10 raised to minus 19 coulomb. And N stands for number of electrons. This N should be number. Number means integer, which means you can take up the values 1, 2, 3, 4, etc. For example, any material can have a charge of, say, for example, 10 electronic charge or 25 electronic charge or 36 electronic charge. But it is not possible for any material to have a charge of 11.3. It is not an integer, right? So quantization of electric charge mathematical formula is important. You have to solve problems based on this. Q is equal to N times E. E is 1.6 into 10 raised to minus 19 coulomb, and N stands for number of electrons. It can take up the values 0, 1, 2, 3, etc. If you take it as 0, which means there is no charge at all. Okay. Fractional numbers are not possible, only integral numbers are possible. So any charge has to be integral multiple of electronic charge. It is quantization of electric charge. So we studied all the properties, all the important properties of charge. How can you define charge? How can you represent symbolically in which unit you can measure charge? And one of the important property of electric charge, it is quantization of electric charge, right? Now we are in a position to define what is electric current. Electric current is nothing but the amount of charge flowing through a particular area in unit time. This is how you can define electric current. It is the charge flowing through a given area in unit time. That is charge per unit time. So mathematically, we can write I is equal to Q by T, charge by time. It is always better that we study formulas in triangular form, because sometimes Q and T will be given to you. You will be asked to find out I. So that time you can easily remember the formula I is equal to Q by T. Suppose if Q, I and T is given, if you are asked to find out Q, Q means I into T. Or if you want to find out time, T is equal to Q by I, right? So it is always desirable to study the formulas in triangular form, so that makes it easier when the other quantities are being asked. I'll show you once again. Q is equal to I is equal to Q by T, or Q is equal to I into T, or T is equal to Q by I. All these are coming from the basic formula I is equal to Q by T. So this is a mathematical formula for measuring electric current. Definition, mathematical formula. After that, what? Unit. What is the unit in which you can measure electric current? SI unit of electric current is nothing but ampere. You can use the symbol capital A to represent ampere. Actually, ampere is the name given after a famous French physicist and mathematician whose name is André Ampere. It is given the unit ampere in order to recognize and respect his work in the field of electric current. And he is considered as a father of electrodynamics also. And when we study any new unit, we have to know how to define this unit. Definition of unit can be done with the help of mathematical formula. That is, we studied I is equal to Q by T. Suppose if you take Q as 1 coulomb and T as 1 second, then what will be the value of I? I will become 1 ampere. So 1 ampere can be defined as the flow of current of 1 coulomb of charge per second. Per second means in 1 second. Okay, so 1 ampere can be defined as the current flowing through a conductor when 1 coulomb of charge is flowing in 1 second. Even though ampere is the SI unit of current, sometimes there will be smaller units given for current. That is, when we are measuring smaller amount of current, we'll be using smaller units. They are milliampere and microampere. These are very common. And when it comes in problems, it is always to be noted that we have to convert it into the proper SI unit. So if milliampere is given, before solving the problem, you must multiply it with 10 raised to minus 3 to make it into ampere. And if microampere is given, microampere will be using the symbol mu A. It has to be written this way, mu A. And microampere, if it is given, you should multiply with 10 raised to minus 6 to make it into ampere. So we studied how to define electric current, how to represent electric current, what is the mathematical formula, what is its SI unit, and what are the other units of electric current. And now, any physical quantity, in order to measure it, we need specialized instruments, right? If you want to measure length, you might use a ruler, a meter scale, a measuring tape, etc., based on which measurement you are going to take. Similarly, electric current also need a measuring instrument. Before coming to how can you measure electric current, there is one more topic to be covered. It is direction of electric current. Electric current is believed to be having the direction. It is accepted worldwide that we have to take the direction of electric current in a direction in which the positive ions are moving or the positive charges are moving. Direction of electric current is the direction in which the positively charged particles are moving, or if you know the direction in which the negative ions are moving, which means direction of current has to be taken as opposite to the direction of motion of electrons. Okay, so conventional direction of current is always in a direction along which positively charged particles are moving, or in a direction opposite to the motion of electrons. And electric current can be measured by using an instrument called ammeter. You will be using it in your lab when you're doing the practicals. This is a device called ammeter. Ammeter will be used to measure electric current. There are different types of ammeters. Some of them will be measuring the current in ampere, some will be measuring the current in milliampere, and some will be measuring the current in microampere. So if the current is measured in milliampere, inside the ammeter you can see it will be written as MA. And these calibrations also might be different in different ammeters. Some of them will be having the calibrations like 0, 50, 100, etc. Some will be having the values as 0, 1, 2, 3, etc. So different ammeters will be having different kinds of calibrations and different kinds of units in which the current will be measured. Basically, we say that the device used to measure electric current, it is ammeter. So we have discussed so many things today, but I always prefer to keep less in your memory, utilize less memory stack. So I'm going to give you what are the points you should keep in your memory stack from today's discussion. One is nothing but the definition of electric current. Everybody might be knowing by now. It is charge flowing per unit area. From the definition itself, you will be able to make the formula for electric current, right? Charge per unit time. It is I is equal to Q by T. And once the formula is done, you should know in which unit you have to measure this. It is Q by T. Q means coulomb, time means second. We can use either coulomb per second or ampere. And the measuring instrument is ammeter, which is connected in series. So what is series? And is there any other way of connecting instruments? Yes, we will be studying about series, and one more type of connection is there, parallel combination, which we will be discussing in the forthcoming video. Now you keep in your mind that ammeter is the measuring instrument. It has to be connected in series. About series, we will be discussing in the forthcoming class. I hope today's class is very much understandable to everyone. Hope you all enjoyed watching this video. Keep watching and subscribe my channel so that you will not miss any of the topics. And keep learning physics and keep it light in your mind. Enjoy learning physics. Thank you for watching once again. Have a great day to all of you.